So imagine opening your laptop tomorrow morning, right? And finding out that your web browser is no longer just this passive window to the internet.
Right, it's not just a viewer anymore.
Exactly. Instead, it's become this autonomous worker, like one that actually reads your screen, understands the context of whatever you're looking at, and, clicks buttons for you.
Which is a huge leap.
It really is. And between April 12th and April 18th, 2026, Google quietly made that a reality. I mean, if you were just skimming the headlines, you might have seen a handful of, standard tech updates.
Sure, just regular press releases.
Yeah. But if you look at the whole board, they orchestrated this massive architectural shift. They pulled artificial intelligence out of those isolated little chat boxes and pushed it natively into operating systems.
Into physical factory robots, too.
Yes, and directly into the fabric of your personal browser.
What's fascinating here is that we are watching the industry transition AI from this passive oracle, something you just query for answers,
right,
into an agentic system.
Agentic.
Yeah, meaning it is being fundamentally redesigned to take independent action on your behalf out in the real world.
Welcome to this deep dive. Our mission today is to cut through all the noise for you. We are delivering a newsroom professional briefing focused entirely on the facts, the data, and the hidden mechanics behind Google's AI releases from this specific week in April.
We're getting into the nuts and bolts.
Exactly. We're going to explore how these systems work, why they occasionally break at scale, and, what it means for you. Okay, let's unpack this.
Let's do it.
So before an AI can act as a reliable agent in your daily routine or, say, on a manufacturing floor, it has to genuinely understand physical space.
Right, which has always been a huge hurdle.
Yeah. And on April 14th, Google DeepMind published a blog detailing Gemini Robotics-ER 1.6. ER stands for Embodied Reasoning. This basically serves as a cognitive layer for physical robots.
The word cognitive is doing a lot of heavy lifting there, but honestly, it is entirely justified.
Really? How so?
Well, historically, robotics has struggled immensely with spatial context. Like, a robot could be programmed to walk a very specific path, but asking it to look at a cluster of analog pressure gauges.
Oh, like in a chemical plant or something?
Exactly, like a sight glass in a plant. Asking it to actually understand what it was seeing, that was incredibly brittle.
Yeah.
But DeepMind co-developed these new capabilities globally with Boston Dynamics.
Okay, wow.
And the model achieved a 93% success rate in reading analog instruments using what they call agentic vision.
Okay, I want to pause on agentic vision for a second, because a 93% success rate implies it isn't just, snapping a photo and running some basic optical character recognition.
Oh, far from it. I mean, a standard camera just takes a 2D grid of pixels,
Yeah.
right? Agentic vision actually maps the 3D geometry of the object in real time.
So it understands depth.
Yes. If the robot is looking at a dial from a weird angle, it calculates the parallax effect. It understands the physical needle, the shadow it casts, the specific curvature of the glass.
Wait, it factors in the glass curvature?
Yeah. And the context of the machine it's attached to. It interpolates the physical world the way a human inspector's brain does.
So it's translating visual noise into spatial logic. That's wow. Now, understanding the world is one thing, but communicating within it is another.
Very true.
On April 15th, on the Google blog, they launched the Gemini 3.1 Flash TTS, or text-to-speech system, globally. And the claim here is that it supports over 70 languages and reframes AI speech as a directable performance.
Which is a great phrase.
Yeah.
Yeah.
But what makes this different from, the robotic voice I get when I use my Maps app?
It's all about the mechanism of control. Most text-to-speech systems just ingest raw text and spit out audio based on a generalized model of human cadence. Very flat.
Right. Turn left in 500 feet.
Exactly. But Gemini 3.1 Flash TTS uses native audio tags embedded directly in the text prompt.
Audio tag.
Yeah, so you aren't just typing words. You are directing the pacing, the vocal fry, the emotional tone. You can even orchestrate multi-speaker dialogues within a single generation.
Oh, so you are effectively coding a voice actor's performance.
Precisely. You're the director now.
Let's look at the numbers, though, because the release notes state this placed Google at the top of the artificial analysis TTS leaderboard with an ELO score of 12,211.
Right.
What does an ELO of 12,211 actually mean for the listener who, isn't tracking AI benchmarks every day?
Sure. So ELO is a rating system originally designed for chess. In this context, it means that in thousands of blind side-by-side audio tests with human judges.
Like a Pepsi challenge for AI voices?
Basically, yeah, Gemini's audio is consistently beating the top competitors by a wide statistical margin.
Mm.
An ELO of 1211 at this stage implies the audio is practically indistinguishable from human speech,
That's incredible and a little scary.
which is exactly why Google baked SynthID watermarking directly into the architecture. Every audio file carries a cryptographic signature proving it was synthetically generated.
A completely necessary safeguard when you're generating hyper-realistic audio. But, here is the friction point. To build models that can perform with that level of nuance, you need unfathomable amounts of training data.
Oceans of it.
Right. And the AI industry is famously running out of high-quality human data on the internet. So on April 16th, the Google research blog published 2 landmark studies tackling this exact data ceiling. Let's start with the first one, Mogen.
Ah, yes. Mogen.
The paper says it uses, and I'm quoting here, point cloud flow matching to generate synthetic neurons for brain mapping. That is an incredibly dense string of jargon.
It is a mouthful. Let's break it down. Imagine a swarm of millions of bees flying randomly in a room.
Okay, weird visual, but I'm with you.
That swarm is your point cloud, just raw, unstructured data points. Flow matching is like introducing highly specific invisible wind currents into that room.
To gently guide those bees.
Exactly. Until they perfectly form the shape of a complex 3D biological cell. Mogen is mathematically guiding random noise into incredibly precise synthetic structures.
Which acts as a massive accelerator for scientists trying to map out the human brain.
You got it. It's revolutionizing biological modeling.
Okay, that visual helps a lot.
Yeah.
You are sculpting structure out of chaos. Now, the second study published the same day is called Simula. This is a framework for generating high-quality synthetic training data for foundation models.
Right. And this is a big deal.
Well, I need to push back on the entire premise of synthetic data here, because if you train an AI on data generated by an AI, doesn't that just create a giant echo chamber?
That's a very common concern.
Like taking a photocopy of a photocopy? Over time, doesn't the image just degrade into a blurry, hallucinating mess?
It absolutely does, if you
Yeah.
use the naive approach. I mean, if you just ask a model to spit out a billion random sentences and then train a new model on that output,
You get garbage.
yeah, you get exactly what you described. It's a phenomenon called model collapse. But the Simula framework relies on a concept called mechanism design,
Meaning what, practically?
meaning it treats data generation as an intensive engineering problem. Instead of just asking the AI to imitate human text, Simula forces the AI into a structured hierarchical reasoning process from first principles.
Wait, so it's not just mimicking?
No, it builds a map of the conceptual space, say, quantum physics, and identifies the logical gaps. It then generates data specifically designed to bridge those gaps, governed by strict rule sets.
So it acts as a highly disciplined curriculum for the AI rather than a giant echo chamber.
Exactly. And by doing this, it significantly reduces the coverage gaps and hallucinations that plague current models.
So it isn't just memorizing its own past answers, it's actually being forced to show its work and generate novel logic.
Right. It's a fundamentally different approach to synthetic data.
That makes sense. But a smarter model sitting on a server in a research lab doesn't really change your daily workflow.
No, it doesn't.
But between April 15th and 16th, Google launched a native macOS app for Gemini globally, and alongside it, a massive Google Chrome update in the US introducing AI mode. This is where the lab research finally hits the consumer.
And the Chrome update fundamentally alters the mechanics of web browsing. I mean, think about how you do deep research right now.
Lots of tabs. Lots and lots of tabs.
It is a constant, frustrating game of tab hopping. You have PDF open in one tab, you search for a term in another, you copy a link to a third.
And you lose your train of thought completely.
Exactly. AI mode in Chrome Desktop eliminates that. When you click a link, you can open the web page side by side with an active AI conversation panel natively in the browser.
Meaning the AI shares your exact visual context.
Yes.
You don't have to explain what you're looking at. It is sitting right there, reasoning across your class notes, your PDFs, and the live web page simultaneously.
It's a huge time saver.
And on April 14th, they introduced a companion feature for US English users called Skills in Chrome. You can save frequently used Gemini prompts as reusable one-click tools.
This is one of my favorite updates.
You just hit the / key, select your skill, and it runs across the current page.
Which transforms the browser from a passive viewing pane into an active automation layer. Those everyday prompts essentially become permanent microagents.
See, it sounds exactly like building a macro in a spreadsheet, but instead of a macro that, mindlessly clicks cell B4 every time.
This macro has a brain.
Exactly. It can read the web page, understand the semantic context, and adapt its actions. But, and I have a serious concern here about trusting this brain.
Okay, let's hear it.
On April 16th, Google rolled out a feature called Personal Intelligence for Gemini AI Plus Pro and Ultra subscribers. It uses a new image model, Nano Banana 2,
Great name.
to generate personalized images based on your private Google Photos library.
Yes, the goal is to solve the prompt gap. It is notoriously difficult to describe the exact likeness of your family members, your pets, or, your living room to an AI. By connecting your Google Photos library, the model has access to your longitudinal context.
And that is exactly my concern. If I ask it for an image of my dog playing on the moon, it knows what my specific dog looks like.
Right.
How can a user trust this system with deeply private family photos? I mean, how do we know my dog's face isn't going to end up in the training data for a global Gemini model used by millions of people?
Well, that is the critical architectural distinction Google highlighted in the release. The system does not use your private library to train the base model.
It doesn't.
No. Instead, when you make a request, the AI creates a temporary, localized reference map of your photos.
Okay.
It uses that map to guide the generation of the specific image you asked for in real time, and then that context is essentially burned.
Oh, wow.
Yeah. Your personal data acts as a temporary lens for the AI to look through rather than permanent ink added to its global memory.
Okay, so it's a strict ephemeral boundary between the user's data and the model's underlying weights.
That's it.
That brings up the broader topic of developers and infrastructure. Because if Google is making it this easy for consumers to spin up personalized agents, they're also democratizing it for developers.
Very true.
On April 15th, they introduced prepay billing for the Gemini API within Google AI Studio, initially rolling out in the US. Developers can now fund their API balances upfront against a Google Cloud billing account.
Now, this might sound like a dry accounting update, but it removes the single most cited blocker for widespread developer adoption,
The fear is the bill.
the fear of the bill. Before this, Cloud AI was largely post-pay. If you're a student prototyping an app or an indie developer, the lingering fear is that you accidentally leave a script running overnight, it gets stuck in a loop.
And you wake up to a $10,000 cloud computing bill?
Right?
The infinite loop of financial ruin.
Exactly, the fear. Prepay billing establishes hard, predictable spend caps and auto reloads. You put in $50, and when the $50 is gone, the API stops.
It just cuts off.
Yeah, provides total financial certainty.
So we've made it incredibly cheap and financially safe for any developer to spin up an AI agent, but that democratized access introduces a terrifying scaling problem, doesn't it?
It does create some massive challenges.
How do you govern a system where millions of people can deploy agents that interact with the real world? As the AI gets more capable, the guardrails have to get stricter.
Absolutely.
So on April 17th, Google DeepMind globally updated its frontier safety framework to version 3.1.
This is a crucial evolution in governance. Historically, AI safety frameworks have been heavily biased toward extreme existential threats, what they call critical capability levels.
Like Skynet stuff.
Right. Things like an AI helping someone engineer a bioweapon. But version 3.1 introduces tracked capability levels, or TCLs.
Creating a middle ground.
Precisely a middle ground.
Yeah.
TCLs create a new tier of mandatory monitoring between standard everyday mitigations and those critical catastrophic risks.
Okay, so what does that look like in practice?
It shows that frontier labs are operationalizing their risk management. They're building systems to catch less extreme, subcritical manipulation risks, like localized phishing campaigns or automated social engineering.
Oh, catching them much earlier.
Yeah, much earlier in the development lifecycle, before the model ever reaches the public.
And we actually have hard data from this week proving what that safety governance looks like at an enterprise scale.
We do?
On April 16th, the Global Ads Safety Report dropped. It revealed that Google's Gemini-powered detection systems blocked a record 8.3 billion ads and suspended 24.9 million accounts globally in 2025. It is catching more than 99% of policy-violating ads before a user ever sees them.
That volume is staggering. It proved that Gemini is no longer just a generative tool. It is functioning securely as a massive global defensive filter for malicious content.
But let me push back on that volume for a second. Here's where it gets really interesting. Blocking 8.3 billion ads sounds great on a slide deck, but isn't there a massive risk of a machine gun approach here?
What do you mean?
Like where the AI is just firing wildly at anything remotely suspicious, and innocent advertisers are getting caught in the crossfire?
That is the historic vulnerability of automated moderation, right? The false positive rate.
Yeah.
But the crucial metric buried in that same report addresses that exact concern.
Okay.
The implementation of Gemini actually resulted in an 80% year-over-year reduction in incorrect suspensions.
Wait, really? And an 80% drop?
Yes. So, to use your analogy, it is not a machine gun firing blindly into a crowd. It is a highly calibrated sniper rifle.
Okay.
It's vastly more nuanced in its contextual understanding than the legacy rule-based systems it replaced.
An 80% drop in false positives is a massive win for advertisers. However, operating at this global scale exposes the physical realities of cloud infrastructure. This tech isn't magic. It runs on servers that can break.
And they did break.
Right. Between April 15th and 17th, developer API change logs and operational reports detailed severe service disruptions for Google AI Studio and the Anti-Gravity IDE globally, with the IST region taking a particularly heavy hit.
These were significant outages. Developers were hit with cascading 503 error codes. But more uniquely, they encountered what are called agent termination loops.
What exactly does a termination loop look like from a developer's perspective?
Well, imagine an autonomous agent deployed to sort a database. It hits an unexpected error, fails, and immediately tries to restart the task.
Okay, pretty standard.
But then it fails again and restarts again, executing this loop thousands of times a second. And during this disruption, there was a devastating quota sync bug.
Oh.
Yeah. Developers woke up to find their daily API quotas completely depleted, but because of the disruption, the system hadn't actually returned any model responses.
Oh, man. So they paid the computational cost without receiving the work.
Exactly. It's incredibly frustrating for devs.
It is a stark reminder of the growing pains we face right now. We are watching AI transition from an experimental side project into mission-critical infrastructure. And when mission-critical infrastructure has a quota bug, global businesses literally stall.
It definitely forces the industry to build more resilient routing and failover systems. But while the back-end infrastructure was struggling, the front-end software design saw a major breakthrough.
Right. On April 16th, Google Accessibility introduced a framework globally called Natively Adaptive Interfaces. And I think this might be one of the most fascinating concepts from the week.
It's brilliant design philosophy.
Typically, a developer builds a static app, right? And then bolts accessibility features like a screen reader or high contrast mode onto it after the fact.
That's an afterthought, basically.
Exactly. But this framework uses AI to inherently build adaptability into the user interface from the ground up.
The AI is continuously reading the user's interaction. It dynamically adjusts the layout, enlarges text scales, or simplifies the navigational menus in real time.
Just tailored to the user.
Yes, specifically tailored to an individual's cognitive or physical needs at that exact moment.
It is a digital manifestation of the curb cut effect.
It's exactly. When city planners cut a ramp into a sidewalk curb explicitly for wheelchairs, they found it ended up benefiting everyone.
Right. Parents pushing strollers, workers with heavy carts, travelers with luggage.
Natively adaptive interfaces prove that when you design an AI explicitly for the disability community, you don't just solve an accessibility problem.
You create a better product.
Yes, you create a deeply flexible, superior interface that naturally adapts to any user who might be, temporarily overwhelmed or visually fatigued.
And if those safety rails, those highly accurate enforcement models, and those inclusive design frameworks are actually holding up under pressure, it explains the final piece of the puzzle we saw this week, the real-world enterprise adoption.
Which is really picking up speed.
On April 14th and 15th, Robotics and Automation News, along with the DeepMind blog, reported that Boston Dynamics integrated that Gemini Robotics-ER 1.6 model we discussed earlier directly into its Spot robot fleet.
Specifically into their Audit AI visual inspection platform. This moves the technology past mere research previews and staged laboratory videos.
It's out in the wild.
This is the first publicly reported commercial deployment of a foundation model, acting as a live, autonomous reasoning layer for an active robotics fleet.
That's huge.
These robots are out there inspecting complex industrial facilities and reasoning about physical hazards using Gemini.
The digital brain is officially navigating the physical floor, and we saw a similar leap in the public sector. On April 14th, the UK Department for Transport deployed a Vertex AI and Gemini-powered consultation analysis tool.
This is a great use case.
When a government proposes a massive new infrastructure project, they are flooded with tens of thousands of free text public responses.
And analyzing that data manually takes vast amounts of bureaucratic resources, months of work.
But this tool reads and analyzes those massive public consultations, slashing the processing time a months down to mere hours.
While maintaining up to 90% accuracy.
Which is incredible, and the projected savings are up to £4 million annually. It is a definitive proof point for the value of generative AI in driving public policy efficiency.
But, driving efficiency in policy and manufacturing inevitably means reshaping the human workforce.
Right. Integrating AI into the global economy requires preparing the workers whose jobs are about to change. So between April 13th and 14th, Google.org announced a massive wave of funding.
They're putting serious money behind this.
They injected a $15 million expansion into the Digital Futures Fund for think tanks. They also granted $10 million to the Manufacturing Institute to train 40,000 workers, and another $10 million in partnership with the Johnson & Johnson Foundation for rural healthcare workers.
This positions Google as a proactive architect of the future labor market. They are developing the exact models that will transform blue-collar manufacturing and healthcare diagnostics.
So they're trying to get ahead of it.
Right. By funding targeted training directly in those sectors, they're attempting to bridge the skills gap before the disruption becomes unmanageable.
Now, looking closely at that $15 million expansion to the Digital Futures Fund, the list of think tanks receiving funding is highly notable. You have organizations like American Compass on one side, alongside groups like the Urban Institute on the other.
Yes.
Google is explicitly funding research from deeply contrasting ideological viewpoints.
Well, if we connect this to the bigger picture of global integration, that approach is really a necessity.
Oh, so?
The macroeconomic impact of AI is too broad to be viewed through a single lens. Developing labor policies, regulatory frameworks, and governance structures that can actually survive shifting political climates.
It requires input from everywhere.
Exactly.
Yeah.
It requires research that incorporates the full spectrum of economic philosophy.
So what does this all mean for you? Let's take a step back and look at the whole board again. Between April 12th and 18th, 2026, Google didn't just tweak a search algorithm or release a slightly faster language model.
Yeah, they went much further.
They pushed agentic AI natively into the Chrome browser, fundamentally eliminating the way we tab hop for information.
Yeah.
They integrated it natively into Mac desktops.
They gave physical Boston Dynamics robots the ability to read analog gauges in real time.
And they started retraining 40,000 manufacturing workers to work alongside this intelligence. They established prepay financial guardrails for developers, caught billions of bad ads with surgical precision, and laid the software foundation for interfaces that adapt to the human rather than forcing the human to adapt to the interface.
The overarching narrative of the week is infrastructural embedding. The isolated chat window is becoming obsolete.
It's just fading away.
The intelligence is being woven directly into the background processes of the tools and physical spaces we interact with every single day.
Which leaves you with a final thought to mull over as you close your browser today. For the last 3 years, the entire conversation has been about prompt engineering, how humans can learn to talk to AI to get the best results.
Right. The burden was on us.
But if AI is no longer a destination, you have to actively seek out if it lives natively in your browser, your inbox, your accessibility tools, and the robots inspecting the factories that build your products.
The paradigm flips.
The real question isn't how we learn to talk to AI anymore. The question is, how will you adapt when the physical world around you starts intelligently anticipating your needs before you even ask?
It's a completely new world.
Thank you for joining us on this deep dive. We will see you next time.